Welcome to the presentation on exponents. So first of all, let's just figure out what an exponent is. So if I write 2 to the third power, what I'm actually saying is that I'm going to multiply 2 times itself 3 times. So it's 2 times 2 times 2. And we know 2 times 2 is 4, and 4 times 2 is equal to 8. When you first are doing exponents, you're tempted to think that 2 to the third is equal to 2 times 3. But the difference is 2 times 3 actually means 2 plus 2 plus 2, which equals 6. So a way you could view it is exponents are to multiplication just as multiplication is to addition. I hope I'm not confusing you. Let's do a bunch of more problems, and hopefully it'll become self-explanatory. So 4 squared, well, that just equals 4 times 4, which is equal to 16. 5 to the third power, well, that would just be 5 times 5 times 5, which equals, well, 5 times 5 is 25 times 5, and that equals 125. I think you're getting the picture now, and every time you'll do it, you'll be able to figure it out, and then when you come back a week later, you might forget, and you'll say 2 to the third. Oh, that's 6, because your brain will say 2 times 3, but you just have to remember, no, that's 2 times itself 3 times. So it's 2 times 2 times 2. Let's do some more. So what happens if I have negative 3 to the second power? Well, let's just think it through. That equals negative 3 times negative 3. And what's a negative times a negative? Right, it's a positive. So that equals positive 9. Let's figure out what negative 3 to the third power is. Well, once again, we could just write it out. It's negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3, we already figured out that's 9. And we have to multiply that times negative 3. And now we have 9 times negative 3, they're opposite signs, so we get negative 27. So that's interesting. When you have a negative number to the second power, you get a positive number. You got, in this case, negative 3 squared equaled 9. And when you had a negative number to the third power, we got another negative number. So if you think about it, whenever you have a negative number to an even power, it becomes a positive number. And whenever you have a negative number to an odd power, it becomes a negative number. I hope I didn't confuse you. Maybe this will hit the point home. So negative 1 to the first power, well, that just equals negative 1. Negative 1 to the second power would equal negative 1 times negative 1. And we know that that just equals 1. Negative 1 to the third power, well, that's negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1 times negative 1. Well, that's negative 1 again. And negative 1 to the fourth power is negative 1 times negative 1 times negative 1 times negative 1. And all the negatives end up canceling out, and you get a 1. So you see that? When we did it to the first power, we got a negative 1. When we did the second power, we got a positive 1. We get to the third power, we got a negative 1 again. We did the fourth power, it became positive again. I hope I'm not confusing you. Let's do some more problems. If I were to say 5 to the fourth power, let's say negative 5 to the fourth power. Well, that's negative 5 times negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is positive 25. And then we can just do it this way. We could say, well, negative 5 times negative 5, that's positive 25 as well. And 25 times 25 is equal to 625. So there's really nothing that we're learning new here. It's just multiplication. When we say negative 5 to the fourth power, we're just multiplying negative 5 by itself 4 times. Now let me show you I'll maybe do another module on explaining this in terms of why this works out intuitively. But one thing to remember is anything to the 0th power equals 1. So 1 to the 0 power equals 1. 2 to the 0 power equals 1. 1,000 to the 0, that's a 0 power, equals 1. And anything to the first power just equals a number. So 15 to the first power, that equals 15. Negative 3/5 to the first power, well, that equals negative 3/5. And now, just to hopefully fully confuse you, I'm going to add one more element here. I'll do a fraction. So if I said negative 3/4 to the second power, I think you might be able to work this one out. You might want to pause it and try it yourself. Well, that just equals negative 3/4 times negative 3/4. So you multiply the numerators and the negatives. Negative times a negative is a positive, so it becomes 9/16. And you might notice that 9/16 is the same thing as if we had negative 3 squared over 4 squared. I don't want to confuse you too much, but later on we'll see that this is actually one of the properties of exponents. That if you raise a whole fraction to an exponent, it's the same as raising the numerator to the exponent divided by the denominator of that exponent. Let's do a couple more. So if I said 5/12 squared, well, that equals 25/144. 5 times 5 is 25. 12 times 12 is 144. If I said, say, 2/3 to the third power, well, that's 2/3 times, the dot is just another way to write times, 2/3 times 2/3. And that equals 2 times 2 times 2 over 3 times 3 times 3. This numerator, 2 times 2 times 2, well, that just equals 8. The denominator, 3 times 3 times 3, well, that just equals 27. So we have 2/3 to the third power equals 8/27. I think you might have gotten the picture by now. Pretty much, if you have any number, let's just say you had the number a, I hope I don't confuse you using these variables, to, let's say,